Okay, our last page here goes through the last pieces that we need for our hypothesis testing. 30. It says, suppose you are using alpha being 1% to test the claim that the mean does not equal 48. Using a p-value, you are given the following sample statistics. Find the p-value. Well, we have a two-tailed test. We want to calculate first our test statistic, which is going to be 46.8 minus 48 divided by our standard deviation, which, remember, this symbol is interchangeable, over the square root of 85. Okay, so for that, we get 46.8 minus 48 divided by 5.2 over the square root of 85. We get negative 2.13. So to find our p-value, we have to double the area to the left of our z-score, because it's not a one-tailed test, it's a two-tailed test. Oops. We get 0.0332. And number 31. Suppose you're using alpha being 0.025 to test the claim that the mean is less than or equal to 20 using a p-value. Well, using a p-value, we do need to know the type of a test we have. Previously, we had a two-tailed test, so we had to times our tail by 2. In this one, our alternative hypothesis is going to be greater than 20, which means we have a right-tailed test. So when I calculate my p-value, we're going to have to find the area to the right of our test statistic. So again, to calculate that test statistic, this is our equation. I'm going to do 20.9 minus 20 divided by 2 over the square root of n, which is 40. Okay. So again, in parentheses, 20.9 minus 20 divided by 2 over the square root of 40. We get 2.85 for our z-score. Now we find our p-value by doing normal CDF, 2.85 to 10. And our p-value is 0.0022. 32. Find the standardized test statistic for a sample with the following. Round to 3 decimal places. Test statistic we find from our formula, x bar minus the mean divided by the standard deviation over the square root of n. We previously found it in 30 and 31 to find the p-value. So x bar is 102, mu is 108, the standard deviation is 15, and then our sample size is also 15. We don't need alpha here. So again, it's very careful that we use parentheses in our numerator as well as our denominator. Sorry, it's 102 minus 108 divided by 15 divided by the square root of 15. We get negative 1.549. T is rounded to 3 decimal places, and remember Z is 2. 33. Determine the standardized test statistic Z to test the claim about the population proportion. So our test statistic for P is P hat minus P divided by the square root of P times Q over N. P hat is 0.511. P is 0.56. P is 0.56. Therefore, Q, remember, is 1 minus P, because P and Q together have to equal 1. 0.44, and n here is 72. Okay, in our calculators, okay, again, we do need to use parentheses here. 0.511 minus 0.56 is our numerator. The denominator, if your square root starts off with a parentheses, that's fine. We're just going to close it in the end. You get negative 0.84.